Hey guys, so in today's video we're going to be doing another web exploitation. As you can tell, I really do like these. I am really interested in web vulnerabilities and stuff. Today the challenge we're doing is called It Is My Birthday. I'm going to show that screen in a second, but I did want to say, I know the last TTF was kind of a mess, but if you guys really do want to see more binary exploitations, just let me know. I'm gonna try to be a lot more prepared next time and really understand what's going on. That was definitely my fault. I'm here to learn and I should put in the work to do so. So anyway, let's go into this challenge. So it is my birthday. I sent out 2 invitations to all of my friends for my birthday. I'll know if they get stolen because the 2 invites look similar and they even have the same MD5 hash, but they are slightly different. You wouldn't believe how long it took me to find a collision. Anyway, see if you're invited by submitting 2 PDFs to my website. Okay, so this is kind of cool. So MD5 hash, okay, let me explain a hash. So a hash is, I mean, it's used for integrity reasons, but it's pretty much just I want to say unique, but MD5 isn't very unique. Okay, I'll use the word unique for now and explain why I'm iffy using that. So a unique string of characters that identify files. Yeah, or data. Let's just go with files. And the reason why I'm iffy using unique is because, as you can see here, based off the description, the 2 PDFs we're going to be working with are collisions. What that means is, so I don't remember how to get an MD5 get MD5 on Windows. I know you can do oh, is it checksum? Cert util? Was that a thing? Let me find a file that I can work with real quick just to show you a quick little example. Let's use a file from the last CTF. So it's cert hash file von C MD5. Let's see if that works. Cool. So this is the MD5 hash of von C. So if I were to go and take a look at that file and even make the slightest change, why isn't this opening? Come on now. There we go. So say I get rid of this, something that's not gonna break it, I guess. Let's put if 1. It should change the hash of the file. As you can see, the hashes are different. If I change this back, I believe it'll be the same. Yes, we have the exact same hash. So as you see, when the data changes, so does the hash. And this goes with any type of different hash like SHA-1, SHA-256, blah blah blah. But today we're only focusing on MD5. Another important thing to note is, if I were to change the name of the file, any type of metadata does not affect the hash, only the actual data of the file. Why that is, I don't remember. I probably learned some forensics, but it does not. So if I were to change, I believe in the created date, modified, all that. Well, yeah, actually, yeah. If I were to change all this, it would be true because as we saw here, I modified this by putting in if 1. We got a different hash. I changed it back, also updating the modified date, and we got the same hash again. So if I were to change the file name, even the extension, exact same thing. So now that we have that out of the way, how do we solve this? So let's open this up, and all we have is to input 2 files. Okay, first thing I like to do is take a look at the source code, and yeah, there's not really much going on. We know there's an index.php. Let's see if we can maybe take a look at that. Nope, we can't. That's the file we're in. What if we put s to view the syntax of PHP? And we can't take a look at that either. I'm actually not familiar with what this does. I think that's what does. Let's take a look at this Stack Overflow. You have to encode the data. Okay. Okay, so it's pretty much kind of just like a header thing, like things you see like in a header of the encoding. It doesn't really pertain to us. The important thing here that we need to take note of is this. I know if they get stolen because the two invites look similar, so they may have the same content, which they do. No, they have the same MD5 hash, but they are different. So, and he says it's a collision. We need to find the collision, meaning the data within the file is going to be different. However, when we hash the file using an MD5 hash, we get different hash values, which is very possible using MD5, which is why, like, for standard, I think we use at least like SHA-256, because to my understanding, even SHA-1 you can find collisions for, which is a big no-no. The reason why is, say for example, like logging in and creating accounts. A lot of the time when you create an account, say your password, for example, when you create an account and you enter a password, it's stored somewhere like in a database. And obviously it would be very insecure to store it in plain text. Like if my password was Jason123, I don't want to, as like, a web developer and stuff, I don't want to store that into my database just cleared like that. No, we want to hash it. So we would run, well, I'm not actually going to show you, but we would run that password Jason123 into some sort of hashing algorithm, preferably like SHA-256, something else, not MD5. That way, we don't know the text. So how it works for the most part is when you log in, you enter your password Jason123. Then the server gets that, hashes it using the same algorithm, and compares the hash with the hash in the database. And if they're the same, then you log in. That's where the collision problem is, because say Jason123 and Mason562, when you hash them using the exact same hashing algorithm and they get the same hash, if you were to compare that hash with the hash in the database, they would be the same, meaning that person would log into, say, Jason's account using the wrong password, but it's okay because the hashes are the same. So I hope that makes sense, but not the point of this this challenge, but it's a good thing to know. So the first thing I was thinking of was, okay, so what data can I use that would provide me this collision? And that's where I found this neat little thing. I actually found a Stack Overflow answer, and they actually linked this. And I guess Mark Stevens did some sort of like research, and he found out that these two messages, the data within them return the exact same hash in MD5. Let me read something. Okay, so what I did, just straight up just downloaded these. I'll put this in the description. Shout out to Mark Stevens. Honestly saved me so much time. Okay, so I downloaded these. Close that, and let me bring this over here. I don't need this. Oh, it's CLS. Okay. So as you see, we have two binary files in here. And as I mentioned, the hash is not altered if you change metadata, like the, what is that called? The file extension. And a cool thing is, I actually learned this in my OS class, is in operating systems, I guess not preferably, specifically in Unix, the file extension doesn't mean anything to the OS. It doesn't mean anything. It's only kind of like a reference or a little note to the user of what kind of file that may be. So for example, in Unix, this can be docs, PDF, PNG, but the OS always interprets it the exact same way. It's up to the user to determine what, kind of application and stuff they want to use with that file. In Windows, it's kind of the same thing. However, they have like special registers and stuff that say, for example, if the file ends with .pdf, then it knows to use like Adobe, whatever the Adobe Acrobat. Okay. So now, what was it? Util. I'll just do this. MD5 and then just change the file name. So here I'm going to show you that these two have the exact same hash, and I could even show you the data. So this is the hash, the MD5 hash we get of message 1, and then let me do the same thing for message 2, and we get the exact same hash. Let me see if I can actually view the contents of this file. It doesn't really look like it. Maybe I can just do, a little notepad. Okay. Well, if the data was the same, we would see the exact same output. I believe this is just binary data, so that's why it looks, like symbols like this. But yeah, as you can see, the data are very different because, we don't get the same result in here. However, we do get MD5 collision. So in theory, this should work to solve the challenge. And boom, there we go. Here's the flag, and here is actually the code that this website's using. So all it does is get the type of file, because it's going to check if it's a PDF, the size of it. It checks, I guess, just to prevent like an overflow of the size. It gets the contents of the files. I'm pretty sure, yeah, it checks the contents to make sure they're the same. MD5, and then it checks both the hashes, make sure that's the same as well, and then it puts on the highlight for this PHP file, which is how we're able to see all this. And inside of this is where the flag is. So yeah, this challenge was pretty cool, and I think, I was able to teach you guys a few cool things, and yeah, I thought it was fun. Hope you guys enjoyed. Please subscribe, like, do all those things YouTubers say, and I think next time we do forensics, so stay tuned for that. Thank you.